Okay, so it says use your answer in part A above to find the coordinates of the orthocenter of the triangle ABC. Well, the orthocenter is the intersection of two altitudes. Now, you've already actually, in part A, is what you've done is you've actually found one of these altitudes, which is shown in red in the diagram. Okay, so it's starting at a vertex and going perpendicular to any other vertex. So I'm going to repeat the exact same procedure in which I did in A, but just for a different, to create a different line. Okay, so I'm going to get the slope of AB. Okay, so I'm going to get the slope of AB, and then I'm going to come at that from C. Now, something to note about this as well. Keep in mind that this is actually an obtuse triangle. Okay, so because that's an obtuse triangle, that means my orthocenter is going to be outside the triangle. Okay, and it also means that a perpendicular height can be outside the triangle as well. So that's important to note, because sometimes things like that can put us off. Okay, so just getting the slope of AB. Now I know I'm not spending time on this, but again, it's just filling into your slope formula. So I get a slope of AB to be -5. So the perpendicular slope is turning that upside down and changing its sign. So -5 will become 1/5 when we do a sign change. Okay, now remember, I'm after getting the slope of AB. So that means, so my AB is along here. So that means I need to come at it from the other vertex. So the vertex I need to come at is C. So my M is 1/5. And then my C here that they told me was -3, 4. Okay, so making up an equation using y minus y1 equals m times x minus x1. We have y minus 4 equals 1/5 of x plus 3, because watch the sign change. 5 times y minus 4 equals x plus 3. So 5y minus 20 equals x plus 3, or x minus 5y plus 23 equals 0. Okay, so now at this stage what you have found now is the equation of the perpendicular coming from C. Now if you look at here, the perpendicular coming from C to AB, you'll notice that I'm going to need to extend, okay, and I'll just do it in a different color. I'm going to need to extend my line, because if you look at it there, there's no way anywhere along AB I'm going to make right angle. Okay, so I need to extend it. Okay, so I need to extend out my line AB. So I'll do that first. Okay, so just making my AB a bit longer, just so you can see it. Now this is not necessary, just to explain it. So there's my AB. And now I'm going to make and draw C perpendicular to that. Okay. So the altitude there now is in blue. Now we can already see my answer. Now I knew my answer before I started. So that's my answer there, and you can see that my orthocenter is outside the circle. So how am I going to find that? Well, all I need to do is I need to get the point of intersection of the red altitude and the blue altitude. Okay, so the red altitude and the blue altitude. So there's one of them, one equation, and the other equation was 3x minus 2y. We got this from part A. So 3x minus 2y minus 9 equals 0. Okay, so I'm going to multiply this top one by minus 3. Okay, and that will give me minus 3x plus 15y. Sorry, that's not equal to, equal to 69. Okay, now all I've done there is I've brought that to the far side. I probably should have done that first, but not to worry about it. Okay, and then my other one, 3x minus 2y equals 9. They disappear, and I get 3y equals 78. So y is equal to 6. And then to go with that y, I'll just find an x. So x minus 5 times 6 equals minus 23. X minus 30 equals minus 23. So x is equal to 7. So that means 7, 6 is the orthocenter that we require. Okay, and that's what I have on my diagram. Now keep in mind it's outside the triangle because it's an obtuse triangle. Okay, and how did I find it? I got the actual point of intersection of two altitudes.